is no such data type as strings in C. So what is a string then? Watch the video till the end to have a quick demo on strings and to know about the common mistakes that could lead to segment fault and the ways to rectify those. So what's a string? String is a sequence of characters and it is finally terminated by a null character, the /0. And the way you declare a string will be the char data type. So there is a data type as character only and not a string. So char, the variable name, and in square bracket the size of the array. So string is nothing but an array of characters. And the ways to initialize a string statically, we can have the assignment operator and assign a string in double quotes, or you could leave the size array size unsized, and here automatically the number of bytes allocated will be the number of characters plus 1 for the null. That's important to keep in mind. The null is always a mandatory terminating character for a string. Or you could initialize a string with individual character constants like this enclosed in single quotes. In that case, finally we have to include somewhere a /0 as well. Only then it makes it a complete string. Let's now look at several examples to understand strings better. So like we just saw, I have two variables declared and initialized statically. We could use a regular printf along with the format specifiers to display the contents of the string. So when I execute the code, the two strings have been displayed with a space in between. If I had wanted them to come in separate lines, I must have had a /n mentioned there, because on its own printf will not have a formatting done. But there is another function that you could make use of, the puts, the puts, and then I display the first variable there, and I could have had the same puts for the second variable, or for the second variable I'll have the regular printf. Now see the effect of having this included. So the first string has come on the first line and the second string has automatically come on the second line, though I have not mentioned any /n anywhere. Now that's because in a puts function, the /0 gets automatically converted to a /n, and that will cause the cursor to come to the next line before the subsequent print will happen. So that's a difference between a printf and a puts. Now instead of displaying the whole string in one shot, I could display it character by character. So obviously I'll run a loop for that. So let's say I have a control variable I initialized to the subscript of the first letter, and for how long should I traverse until the ith letter is not a null. So we just learned that every string is terminated by the null, and the null is the one that indicates the end of the string. So instead of having a explicit checkers, as long as s of I not equal to null, it's enough to have had a check like what I showed just now, simply s of I, because every character that's not a null character is considered to be true. So as long as s of I is true, incrementing I every time, and since s of I is going to be characters, in my printf I shall include the format specifier %c and get to show every s of I. So this is to print character by character contents of a string. Another method to have use for displaying a string will be making use of the pointer. We haven't learned pointers yet. It's coming up in the next future videos. So here I have declared a pointer p which is capable of storing at a location that contains a character. So char *p is a character pointer. Now between the integer array that we learned earlier and character array, there are certain differences, highlighting differences that we should know. Like for instance, if I had a integer array like this, and at any point of time I try to print using just the array name, we saw that this will display not the contents of the array but some random number, a very big number, which will refer to the base address of the array. So what an array is basically contiguous memory locations, and all those contiguous memory locations, whether 10 or 20 or 100, they are going to be referred using a single array name. So it's important that we maintain the base address intact in order to refer to the contiguous locations. At any point of time, the base address is considered as a constant. A constant is that should stay the same throughout your program run. It should not be altered. So trying to alter the base address will be considered as an error. Now for an integer array, the array name displayed the base address of the contiguous location, but we just saw in a string, in a printf, when I mentioned the array name itself, it was enough for the entire string to be fetched. So that's the first difference between a numerical array and a string array. The base address is enough for all the characters to be fetched until we encounter a null character /0. And the second difference is that if I to use a loop to show the contents of the numerical array, then definitely I must have traversed from the first index until the length of the array to show the contents using that index. So index variable here is a k. So every time I shall print the contents that are there in a of k. So my loop traversal must have been until the entire size of the array. But in case of a string, though my size is a 20, the contents are traversed only until the /0 or the null character is encountered. That is why the loop condition for traversal is different from what we do for a numerical array. The loop condition should be as long as the null character is not encountered. So coming back to the third way of display, where we use a pointer, I'll have my pointer to point to every character in my string. So I'm going to advance my pointer. So starting from the very first letter, I'll advance it to the subsequent letters. Here it's okay to have the pointer to be manipulated or to be pointing at different locations, because my base address is still going to be intact in the variable s. So my pointer, using a loop, I'll have my pointer to take the base address, that's s, and as long as content of p is a true value, every time increment the pointer by 1. So the pointer is going to be pointing at several next locations, and I shall print the character that corresponds to that content of p. So I have to use a dereferencing operator asterisk content of p, and here again I will get the contents of my string. The first code is because of the printf t, and the next displays because of the print that I have done by using the pointer notation. And if you followed what I just said, the string is a different kind. It's got a special feature. Starting from an address, all the contents will be shown until the null character is encountered. So what effect will this code have, where in the place of content of p I just say p? Again, try and understand. P is starting from the base address, and every time I'm advancing p to point to the subsequent location. So address in those locations I'm obtaining using a p. And if I say printf p, see what the effect is. So every I think this will be even clearer if I include a /n. I'll rerun the code. So every string, every part of the string until the null character from the advanced position of the pointer. So pointer is advancing to every letter, and from that point onwards the entire string until null is fetched. So this is what is a feature of a string. Starting from a particular address until the null character, the whole content will be displayed by just using that address. Now instead of initializing the string at compile time, let's read contents of a string at runtime. There are different ways of inputting a string. Just like we had a puts for displaying the string, we do have a gets or gets for reading the string. Disadvantage of having a gets is the syntax goes like this. There will be no way we can keep track of how many characters the user is inputting. So the user can input a string that's longer than 20 characters, and this is one of the several reasons that will cause a segment fault. That is, you're trying to cause a overflow in the buffer memory, and this will cause your system to crash. And for the same reason, the recent versions of C have done away with gets. You no longer can use the gets function. There are other equivalent ways of inputting a string at runtime, are regular scanf. So when it comes to a scanf, we'll have the format specifier, and for reading individual characters we used to have the address of operator, individual numbers or characters. So supposing there was a character variable C and I had to read the content for C at runtime, the format specifier will be a C because it's a character, and I must have had the address of operator and then a C. But when you're reading a string, since the string name itself is a base address, you can straight away mention the name of the string only. There is no need for an address of operator. We'll have the format specifier and the name of the string. So here again there are some limitations. I'll just execute and show. I'll print the value that the user has entered using a printf. So let's give a prompt here, enter a string. So when I execute and I give a string as there, hi there, but when you try to display the contents of the string, it just showed a hi. So what do you understand by this? The scanf will not allow data to be read beyond a white space. So the white space will cause the end of accepting data for the particular variable that's mentioned. So the remaining characters will only stay in the buffer. It will not be stored for the given string variable s. And like before, there's a possibility of a segment fault being caused, a second procedure which will cause a segment fault, because here we are not keeping track of how many characters the user has entered. I could have entered a very long character, very long string that exceeds 20 characters, which is the size of the array. So to have a check on that, there is a variation that you could use in a scanf by mentioning the size that's allowed for the string. So the array has been declared to be size 20. We just learned there has to be one null character mandatorily. So considering that one character for the /0, 19 characters are allowed. So we can provide a size here, and that will keep a check on, even if you're going to enter a very long string. Say for instance, I go on to type a long string without leaving a space, because spaces are not going to be recognized by the scanf. So that definitely is exceeding 20 characters. But because of the mentioning of 19 characters, exactly that many characters alone will be considered and stored for the variable s. So this will not cause any segment fault. This is a remedy for avoiding a segment fault. But what is to be done about the space? If I really want space also to be included as part of my string, then scanf has got another option feature, which is referred to as scan set, where I can say as long as there is no /n. So this scan set is going to be read as any character until a /n. So the caret symbol says other than that character, every other character can be read and stored for s. So when I run the code here, and this time I enter the same string with the space included, and I press the enter key, the string with the space is considered as an input for the variable s. Another method of inputting a value for a string would be to read character by character from the user. So I have a variable declared for reading individual characters, and since we want to put those characters in the appropriate subscripts, I have a variable declared I, and I'll have a while loop which will read the C, which takes a value through a getchar. So getchar is a function which will allow you to enter one character at a time, and as long as that is not equal to a /n, what we're going to do, the character that we have read and stored in C has to go into my string. It has to go into which place? Let's say I'm starting I with a 0. So I could have an expression as s of I plus plus. So because of its because the expression is a post incrementation, we have learnt earlier post expression is use and then change. So it uses a current value of 0 and then increments it to a 1 to accommodate the character in the next iteration. So in that subscript goes my character C. So for how long will this loop happen? As long as the user has not pressed the enter key. And when I come out, I have to terminate. Now this string is only going to have individual characters. I have to terminate that string with a null. So at the point where my I was last incremented, at that place I can assign manually a /0. Here again, to have a check on only 19 characters, because one is going to be stored for the null, only 19 characters are allowed. We could possibly have another check, logical AND. The value of I has to be less than 19. Let's execute the code. I'll enter a series of characters and I press the enter key. That many characters are stored in the string and have been displayed. Another way of entering data at runtime using the getchar. Another method of inputting data, which is considered as the most efficient and popularly used, will be the fgets. The syntax goes like this. It takes 3 arguments. The first will be the array name. The second argument is the size of the array, and the third argument is mentioning of the stdin, the standard input device, that's the keyboard. And now when we try to print the string that's been read, you'll notice there are 2 advantages with the gets. Fgets, it allows strings with spaces, plus it keeps a check on the size, maximum size allowed, and therefore there won't be any chance of a segment fault at all. So when I run the code, I enter a string. Now there is one thing that has to be understood here. After the string has been accepted, along with printing the string, if I try to show the length of the string, so the length of the string can be obtained using a built library function which belongs to the string.h, and the function is referred to as strlen, and the variable that holds a string. Now I will try and show one another data, that is the sizeof. Now there's a lot of difference between sizeof and strlen that's to be understood. The sizeof will return the size of the array that's been declared, whereas strlen will return the number of characters just before the null, excluding the null. So let's run the code again, and I enter the string hello. So the hello has been shown. The sizeof is obviously shown at 20. 2 things to be noted. Why has a strlen shown a 6, and why has the display come in the next line even though I had not entered a /n? Now that's because this fgets, while entering the data at runtime, when I press the enter key, the /n is also stored. So you can visualize this as the way the string has been accepted as the /n and then the /0, which obviously is not the way that we want. So we have to have the /n excluded, and to do that, following the fgets, we need to include a statement which overrides that /n with a /0. Where is the /n occurred? Where has it occurred? That can be found out using a function strcspn, string complement span, and that will find out in the given string the first occurrence of the given character, given string. So in the original string, this can be used for not just for this situation, any string, substring you want to search for the first occurrence, you could have used a strcspn. So the first occurrence where that was found, it's going to return that position, and exactly that position I'm going to include my /0. So it is to be understood as wherever the /n occurred, that is going to be overwritten by the /0. So my string would have terminated exactly after that last character that was inputted. So let's see the effect of having included this. I enter the same word hello. Now the string length is correctly showing a 5. So what's to be kept in mind when we take data at runtime using fgets, following that we must have had this additional line which will overwrite exactly the /n with a /0. Now we'll try and have a look at some commonly used string functions. Now there is no function to convert my original string to its uppercase form in one shot. I have to traverse letter by letter and convert it to uppercase, and for that we have a function called toUpper. So I'm going to traverse my original string until I have reached the null character, incrementing my index every time. We'll assume for now all the original letters are in lowercase. So every s1 of I is going to be replaced with toUpper of s1 of I. So coming out, if I try to print the string, that will be in the required uppercase form. But obviously for toUpper to be used, we must have had a header file, and the corresponding header file required will be ctype.h. Let's execute and see. So the given string has been converted to uppercase. The next function is strcpy. So this strcpy stands for string copy, and it's destination comma source. So into s2 I want to copy s1. So I must have had s2 declared as big as my s1 to hold all the letters. So coming out, if I try and display the new string, the copied string s2, it should have the same content as my original. Now supposing into my new string I wanted fewer characters only to be copied, then I have an option of strncpy, where I can mention exactly how many characters I want to copy from the original. So when I run the code, only 5 characters of s1 has been copied onto s2. Another function called strcat is commonly used. Strcat will stand for concatenate. So assume I had s1 which is initialized to the string hello, and I have the variable s2 that is initialized to the string world. I can concatenate these two, and the syntax goes like this. The first argument is the string which will have the concatenated version. So this is to be understood as s2 is concatenated into s1, and finally I try to show s1 that will have both the strings contents of s1 and s2. So when I run the code, s1 has got the concatenated version of s1 and s2. Now there is a possibility that this string could be having a smaller size, and now when I concatenate, assume the second string is world and 2 exclamation marks. So just now there is no buffer oversize error or the segment fault error, because hello is within 10 characters, world is within 20 characters. But when I concatenate s2 onto s1, s1 is not big enough to hold the concatenated string. So this again is a situation of segment fault arising. Now we can override the situation by having a proper function included, which is the strncat. So strncat will refer to how many characters can go into be concatenated into s1. So s1 already has 5 characters, and we need to reserve 1 for the null. So additionally 4 more characters only can be concatenated. So using an expression something like sizeof s1 minus the string length that is already in s1 mine is a 1 for the null. So that many characters of S2 will be concatenated onto S1. Therefore, when I run the code, I'll have only that enough characters which can fit my size that I have mentioned, and this will avoid any segment fault arising. We look at one last function, strcmp. So as the name implies, this is to compare two strings, and it will always result in an integer value. So let's try and store the result or return value in a x, and my parameters are the two strings that are to be compared. Now strcmp will return a 0 when both the strings are exactly the same, letter by letter, case by case. So if I try to print the result of the compare that is stored in x, you will notice x to store as 0. So a 0 is returned when both the strings are exactly the same. Now if one of it was a different case, though the word is the same, and just now I have made one lowercase and another to be title case, so character by character, when it compares at the point where there is one different character, at that point the result will be the difference in the ASCII of that different characters. The comparison will not continue thereafter. At the point where I encounter a different character, the rest of this array is not going to be compared. strcmp will straight away return the difference in the ASCII of the characters that have been compared. So when I run the code, I'll get a plus 32, a positive value, because we know the lowercase letters have got a higher ASCII than the uppercase letters. So this small a, its ASCII value 97, is being compared with this capital A, uppercase A, whose ASCII is a 65, and at that point they are different. So immediately the return value is going to be, the value is going to be returned, which will be the difference of the ASCII. So 97 minus 65, difference between any lowercase uppercase is always going to be a 32. If it's the other way around, the first string happened to be a uppercase and this happens to be a lowercase a, now you will notice a return value to be a negative value. So strcmp either returns a 0 or a positive value or a negative value. 0 is when both the strings are exactly the same, letter by letter, case by case. So supposing I had the string to be S2 to be holding a different string altogether, so the first character where there is a difference, at that point the difference in the ASCII is going to be returned. Since the first string is alphabetically lesser than the second string, alphabetically is in terms of ASCII values, because it is lesser, the result is a negative value. A following list of codes have been discussed along with solutions, which is available in my GitHub repository, the link as shown below. Please do have a look. And coming up next, we'll learn the user-defined functions in C. Please do subscribe for more videos on C.